Hey guys, this is the second video in Echelon Catapult's Space Training course for the California Cybersecurity Innovation Challenge. Today, we will be talking about two types of space communication networks. The first thing we need to understand is how artificial satellites communicate with Earth. Satellites communicate with structures on Earth's surface called antennae, which is this picture on the right. The satellites send information in all directions using radio waves, which is a type of light we cannot see. The antennae on Earth pick up these radio waves and convert them into information that we can understand. The satellites send lots of information to Earth, things like images and weather conditions. The antennae respond with directions and instructions on what actions to take next. All of this communication is why it's important to have a constant stream of information between all satellites and the Earth. Hence the importance of the space network, which allows all satellites to communicate with the Earth through other satellites. On the left, we see what the satellite communication network would look like without the space network. Every time a satellite moves out of range of an antenna, it would lose its communication capabilities and be lost in space, with no way to contact Earth. On the right is what the satellite communication network looks like with the space network. All satellites are able to communicate with antennae either directly or indirectly through other satellites. The space network is extremely important because it allows all satellites to constantly be in contact with Earth. So, the space network works for satellites that are in orbit around Earth, but what about the missions that go outside Earth's orbit? For example, how would the Apollo astronauts, who were the first men on the moon, communicate with Earth? Or what about Voyager, whose mission is to explore the outer solar system? The original communication system we designed for space had transmissions that acted like a lamp, with signals being sent out in all directions. But these signals were much too weak to get all the way from Voyager to the moon or Earth. So we had to come up with a solution. Instead of the original signals, whose transmission acted like a weak lamp with information going in all directions, NASA engineers designed special spacecraft who transmitted their signals more like a flashlight. The information from the satellites was direct, condensed, and powerful, allowing it to travel much further in space. These high-power signals are absorbed at 3 antenna locations on Earth, all of which are approximately 300 degrees in longitude, or 1/3 around the world. These sites are at Goldstone, California, near Madrid, Spain, and near Canberra, Australia. They are all 1/3 of the way around the Earth, so that no matter what direction the Earth is facing, there will always be an antenna in communication with the spacecraft in deep space. Thank you for watching our second video in the CCIC Space Training series about space communication networks. If you have any questions, comment them down below in chat or send us an email at team@echeloncatapult.org. On the next episode, we will be talking about commercial off-the-shelf technology, or COTS, so be sure to check out this video next.